Welcome to Inheritance. This is going to be a long one, so I'll do my best to make it as short as possible by deferring topics that were already covered those sessions. So you'll hear a lot of this was covered in this session. Please go and look it up if you missed it, and so on, because there's a lot of content to cover in Inheritance compared to the sessions that we've had so far. So in Java, if you hear the word base, parent, and superclass, they're all referring to the same thing. And the words derived, child, subclass, and extended also refer to the same thing. So most of the time in the discussion, I'll be working with parent or superclass, child, and subclass. Those are the ones that I'm mostly used to, but I might also throw in the others. So a parent can have an unlimited number of classes, of subclasses or children, and a child in Java can have only one parent. They can only extend one parent, and we'll talk about why that is in a few. So when a child inherits from a parent, they take after, or rather they will inherit the fields of the parent, they will inherit the methods of the parent, or the nested classes. We covered nested classes earlier. If you missed that session, please go and look it, check it out. So we have fields, methods, and nested classes. So state and behaviors and nested classes. We also talked about how state and behavior are the same thing as fields and methods in Java. So if you missed that, you can check that out. So this is the syntax. We have the class keyword, name of the child class, extends keyword, name of the parent class, and within the subclass there could be new fields and methods to make the child unique. It inherits the fields and methods from the parent, and the child code would therefore be easier to read. So just to make sure this has sunk, this is our parent class database. In Oracle 2, we are extending database. Okay, so our child class can only extend from one parent. I'll demonstrate this by attempting to extend or to inherit from main as well as database, and as you can see, there's an error. So in Java, a child class can only extend from one parent. Why? We'll talk about that in a few. While a parent can have more than one child, endless numbers of children. So class main extends class database. There we go. So a database is extended by both Oracle and main, and it could go on and on. A class can have only one direct parent, and if there isn't a direct parent explicitly here means like the way we said extends database, main extends database, Oracle 2 extends database. If there isn't an explicit parent, then implicitly every class extends from the object class. So object class is from the java.lang package. I'll have this link in the description for you. So java.lang package has class object, and that is the super class. It is the root of all the classes, and it's the only class that doesn't have a parent explicitly or implicitly. Okay, so all classes descend from object, and this is the kind of hierarchy we'd have. There will be a reference link to this image because I got it from the main from the official documentation. So for example, we have object here, we have database here, we could have Oracle 2, and we could have main here. So both Oracle 2 and main can extend from database, and then they could also have other children, other children extending from them, etc, etc. So this is how the descending happens from object downwards, and object is the root. It is the only class that doesn't have any other any parent. So we'll demonstrate more, we'll talk more about object and how you can use its classes in your code, like clone, equal, hash code, and so on. Mostly I think you can, or the most popular ones to work with are to string equals and hash code and such and such. We'll talk more about that, and there will also be a chance for you to practice with an exercise that I will attach in the description. Okay, so let me just erase this. We don't need it. Now, the reason why we work with inheritance is because if there's a class that's already doing what you want to do, it's easier if you derive from it to save yourself from the problems of debugging or rewriting the code instead of writing the code yourself. Avoid reinventing wheel. Everything that you have will be that a superclass have will be inherited apart from its constructors. So these are not inherited, but they can be invoked. So when we discuss the super keyword, we'll see how it's possible to invoke the parent constructor from the subclass. And then inherited here means you cannot use it as it is. I'll demonstrate that in a few when we discuss overriding and hiding methods. Okay, then we have another thing that you cannot inherit is a private member. So you cannot inherit constructors, you cannot inherit private members. If you would wish to inherit private members, the work around it is to work with, for example, getters and setters. We covered getters and setters. If you missed it, please review that session. When you make the getters and setters either public, protected, or package private, depending on the subclass that is going to work with the parent. Let's get to the discussions here. I think I should just separate this, but okay. I wanted all the concepts of inheritance to go together. It didn't make any sense for me to separate them. So if it's long, you can pause, take a breather, and come back and continue. So let me start with overriding and hiding methods. And when we're discussing overriding and hiding methods, and hiding fields too will be featured, we will look at other things that we can do inside a subclass. So let's go to our demo. Using subclass Oracle 2, let's see what we can do. I worked with to-dos, so we can walk through that. Now, from within this main method, we have created an instance of Oracle 2, and what we did is we worked with this argument constructor in Oracle 2 to create the instance of Oracle 2, whose data type is Oracle 2. Okay, now what can we do in a subclass? We can inherit fields directly. So what does that mean? In Oracle 2, there's no field called inherited field. There's only database type, there's only hidden name, there's only same different type. But in the parent class of Oracle 2, there's inherited field with the value inherited field string value. So within the instance of Oracle 2, I can make a call to inheritance field, and I should be able to use it as if it was a field within Oracle 2. So here we go, inherited field. I will refer to this output moving on. Okay, another thing you can do is you can declare a new field in the subclass that has the same name as a field in the superclass, and in that case you will hide it. Hiding will occur even if the data type is different. So in database we have string hidden name whose value is to be hidden in Oracle 2. In Oracle 2 we have string hidden name that is the same name, so it's hidden, whose value is Oracle 2, hit the field. Another hiding that is happening is we have same name different type string whose value is to be hidden as different data type in Oracle 2. And in Oracle 2, we have same name different type whose value is 0 for this of type int. So in the main method, given that as it stands, the hidden name and same name different type are hidden, I should expect to see the values that are in Oracle 2, which is Oracle 2 hit this field and 0. Now, if I unhide these ones, if I don't hide a field as recommended, then in the main method, when I run this again, what I will see are the values from the main class, the parent class. So inherited field to be hidden in Oracle 2 and to be hidden as a different data type in Oracle 2. Okay, very good. You can always practice with this. If you missed that, and practice some more. This code is available in GitHub. The GitHub link is in the description. Okay, another thing that you can do is, let me run this again because I will be referring to output. Other thing that you can do is you can declare new fields that are not in the superclass. This goes without saying. You use this when you want to have your own unique thing going on in your subclass that is allowed. Then we have info. The inherited methods can be used directly. They are. So use as is method. I'm just using it as an example here. It has no functionality in database along with other demonstrations so far. So it is printing accessed from database directly. Use as is should print access from database directly. And therefore, you'll see access from database directly. Alright, that is number 4. Number 5, what else can you do in a subclass? You can write an instance method that has the same signature as the parent method. So we talked about method signatures earlier. If you missed it, please have a look at it. So this one, this method here, connects in the subclass Oracle 2, has the same signature as this method here, connect in the main class. When that happens, we call it overriding. When you're overriding, it's not a must for you to work with this annotation, but it is recommended that you do. Because when you do that, you'll be communicating to the compiler that this is a method I intend to override. So if the compiler will find that this method doesn't exist in the parent class that you have extended, it will error out. It will let you know there's no such method. For example, if I was to say override connect to, it should let me know there's no such method. So make a habit of working with override when you're intending to override. So when you override a method, you can make a call to the superclass. This is the first instance where we are seeing making a call to the superclass, but you mostly use it when you're working with, or when you intend to make a call to the constructor of a superclass. Anyway, no limits, you can also work with it from within a method. So we are making a call to the superclass. So let's go look at the superclass method. Within the superclass, it is taking the parameters or the arguments that will be passed in, and it is setting those arguments as the values for the fields. So we have connection string, username, and password. Okay, connection string, username, and password. And within the parameters, we have this, and it is setting, the method is setting the fields into the parameter, the arguments that will be passed in. Okay, but those are the ones that are being invoked. Yeah. Okay, and then we are printing out. That functionality is the one that is being invoked here. Then we print out connecting to database type and database established. So let's go and see. Yeah. When we call, oh, I didn't really do it. Yeah, I guess I didn't want to go through doing this. So this is a nice practice aim. Please make a point of practicing with this. If you have the strength to add new connection string, new username, new password when you're making a call to connect via the instance of Oracle 2, and have a look-see of what would happen. I think I went with the easy one out, and what I used was print status, which is way easier because it doesn't need me to pass in any parameters. So here we go, print status, which is also making a call to the superclass, print status, and then printing the database type. So the superclass print status, yeah, is printing the connection string, the username and the password, and then this one is printing the database type. So if I go to the output, then I will see the connection string, the database and the password because of the superclass call. Then I will see, the connection string, the username and the password, and then I will see database type is Oracle 2. It's passed in here. It's passed in here. Another thing that you can do is thing 5 is to work with covariant return type. So if you see covariant return type in the description, this is what I'm talking about. We have a method here in the main method called return covariant type. It's of type SQL default. SQL default is an interface here that the database class is implementing. It's taking the parameter SQL default and then it's returning the said parameter SQL default. If you override this method in Oracle 2 return covariant type like this, then it is allowed for you to return a covariant type. You don't have to necessarily return a type of SQL that is SQL default. You can return a type that is a type of SQL default. For example, you can return the instance of database, and that works because database is a type of SQL default, given that it's implementing SQL default. Okay, so this is allowed. When you're overriding a type, you can return the covariant type. That is allowed. Okay, thing 6, you can write a new static method in the subclass, and that will hide the static method in the main in the parent class. So we have a static method test hiding that is to be hidden in Oracle 2, and a static method here test hiding by the same name that has hidden the static method. So if you run that, you should see static method hidden by Oracle 2. You can practice it on your own, but if I was to comment out this one, then obviously it will take from the main class, from the parent class. Another thing to remind you of is I am accessing this via the class name, not the instance. The class name is Oracle 2. This is capital O. When you access static methods, you don't have to go through the instance. You can directly go through the class name because it's a method of the class. If you go through the instance, it will still work. However, it will let you know that it's a static method. You don't have to do that. Just to be like a self-documenting way of letting the reader know that this is a static method. We covered this earlier. If you missed it, please go back to static methods. Okay, you can declare new methods in the subclass that are not in the superclass. So again, as you can declare new fields in the subclass that are not in the superclass, they should serve the purpose that you intend to have in your subclass. And those are the things that you can do in a subclass. So the new method is backup database, backing up Oracle data. Okay, other things, we have casting. So there is implicit casting. We should have covered this in interfaces, but we didn't, so we're covering it now. Implicit casting is where you work with a different type, like type object. Every class is of type object anyway. So you're saying type object, and then the instance you're working with is specific, the target class, like this one, Oracle 2. So Oracle 2 is a type of object. Okay. Oracle 2 is also a type of database. Why? Because it's extending from class database. Oracle 2 is a type of SQL default. Why? Because it's extending from a parent class that is implementing SQL default. So it's a whole chain And that is how you can work with implicit casting. I just used this to demonstrate that. You can also have explicit casting. Explicit casting is whereby db here, variable db, this one is of type object. So if I was to set that variable db to type Oracle, it would not work because Oracle is a type of db of object, but object is not a type of Oracle. So I have to give a promise to the compiler that, yeah, I do know that, and I intend to work with this as Oracle to type. So this is implicit casting. This is how you do it. Before that, the thing to be casted, you work with brackets, and then you pass in the cast. Another thing that you can do in that note is to work with instance of. So if to work with if statements to check if the said thing, like in this case db, is an instance of whatever cast you're making. Okay, so if db is instance of Oracle 2, then do what you need to do. Okay, and so on and so forth. So we'll talk more about if statements, conditional statements later on. I skipped those ones because they are not specific to Java, so I started with the Java rules, but we'll cover them later. It should be smooth sailing when that time comes. So you'll see errors here because the IntelliJ is smart enough to let you know that how about you just make this thing Oracle, and this one Oracle, and this one Oracle. Like, what's the point? That's what it's trying to do, but I leave it as is because I want that point to be put across. As promised, it's gonna be a long one. If you feel like it's too much, take a breather and come back, because we are moving on to multiple inheritance of state, implementation, and type. Everything that I said is going to be covered in the description will be covered, and we are in point number 2. Multiple inheritance of state, implementation, and type. So let's start from the top. Classes can have fields. Yes, as we've seen. Interfaces cannot. If this was an interactive class, I would ask us why interfaces cannot. So if you want to challenge yourself, pause the video and ask yourself why interfaces cannot have fields. They can only have constants. Why is that? Meanwhile, when you're back, and if you didn't leave at all, this is why. It's because an interface, when you write something that appears to be a field such as this one, it is implicitly public static final. So this is what I mean. See, in Java, if you want to have a constant, you work with the access modifier. Public static final. Let me call this pi, the mathematical pi. Oh, it's of data type thing. Double pi. Then I'll set it to 3.14. Okay, I can only remember up to 3.14. Let me leave it at that. Okay, so this is a constant right here. What makes it a constant? The public static final modifiers. See, this can happen. Yeah, this can happen if it's in the case. But in interfaces like SQL default, for example, let me just work with this one that already has constants anyway. SQL all paths, public static final is redundant. It's not required, it's useless. It's grayed out. IntelliJ knows that. Why? Because by default, every quote-unquote variable that you include in an instance is a constant. So if you want to be very extra on that, you can just work with capital letters. Because that's the the conventional way of writing constants in Java. But yeah, as you see, interfaces don't have fields, they have constants. Okay, so we're establishing facts before we discuss multiple inheritance of state, implementation, and type. Classes can be instantiated. because they were designed to be a blueprint. Interfaces cannot be instantiated because they were designed to be a contract. We discussed this in interfaces. When you implement an interface, what you're doing is you're promising that, hey, I will be implementing methods. Okay. Classes cannot extend more than one parent. We are getting to the topic of multiple inheritance of states. Multiple inheritance of state is not supported in Java because Java was trying to avoid confusion whereby there's a parent by the same field name as another parent that is inherited by this class. How do you tell them apart? How do you know which one is being there's too much going on in that? So multiple inheritance of state is not supported. However, classes can implement more than one interface. Why? If you implement more than one interface, there will be no issue about multiple inheritance of states, i.e. fields, because interfaces do not have fields, they have constants. We're getting to multiple inheritance of implementation. So it's possible to implement more than one interface. And when that happens, if the said interface have default methods by the same definition, then there could be an ambiguous method called error when you implement the class. So what you need to do is to override the default method and define explicitly which one of them you're working with. Okay, but you can just override the default method altogether without making any calls to the implemented interfaces. So we have our class SQL1. Class SQL1 is implementing SQL default, which has this definition, connect to defaults, a default method. Then we have SQL default 1, which has the same method or the default method but the same definition. So if SQL1 is implementing both of them, then it is required to explicitly state within it which of the methods it's calling. So you can work with either or. I just used both of them to demonstrate, or it can just override altogether. What it cannot do is to say super connect with defaults. This will not work because it has to qualify it. If it's a static method, of course, you'll just call it explicitly. Because remember, we covered this in interfaces. There are methods that have bodies, and that is static method or default methods. The other is abstract methods. So if you miss this, you can refer to the SQL all paths class interface that we have in the code from GitHub. About multiple inheritance of type, we've looked into that. You can have your interface name as a type, the object name, then instantiate the class like we saw in the main class here. Multiple inheritance of type. Take a breather if you need to. We still have a long way to go to discuss these topics, but most of them will be very short and straight to the point, straightforward topics. So I'll continue on with polymorphism and virtual method invocation. These are only going to be demos. This is why I don't have any note on them here. So polymorphism and virtual method invocation. If you hear a change in modulation in my voice, it's because I also took a break before I came back to continue recording this session. So polymorphism is the ability of something to take more than one shape, or to take, what do I say? To take more than one form. It sounds like a repetition. Polymorphism form. Anyway, in Java, you would see this in the concept of subclassing. For example, this class Oracle database is subclassing class database, and we also have this other class MySQL1 database, which is subclassing the same class database. Now, in our main method, when we call the type database, like we've already discussed that there are different types that you can have or inheritance of types. So when we call database of type Oracle DB or variable database of type MySQL DB, we can instantiate it to different instances of different subclasses. So the JVM will automatically know what is the appropriate instantiation because it looks more at the instantiation side than it does the data type. So it doesn't fixate on the data type, it looks at the instantiation. So thanks to polymorphism, you can then refer to the variable and you make a call to the methods specific to that instance, and it will print different things accordingly. So same parent class, different children. So same type of thing, different forms. That is polymorphism. And the concept of virtual method invocation. Next, the super keyword. So I'll just go back to our reference. So we see where we are. This is where we are. So polymorphism and virtual method invocation done. It was a very short session, yeah. And then we go to the super keyword and constructor chaining. So let's see about that. We've seen the super keyword in different instances. For example, when you want to make an explicit call to a superclass method like we saw in status, you can also use this when you want to make an explicit call to a hidden field. So the way hidden name here has the hidden name in database class. If you wanted to access the hidden name from database class, you can work with super from within the subclass. Now let's go to the super keyword in the context of constructors. So I'll have us all know that implicitly the compiler adds the super call to the constructor of a subclass. We already talked about how every class takes after object. So if it doesn't have an explicit parent, then it implicitly has object as the parent. And this is not required, but this is how it will look like. So we have the constructor superclass, and it's making an implicit call to super, the no argument constructor in object. So I'm just leaving it here so you know how it looks like, but it's really not required. So we have a subclass extending superclass, which is subclassing superclass. Because there is no constructor defined here, doesn't mean that it doesn't exist. There is by default an implicit no argument constructor that is making a call again to super from superclass, and this still works. So we are creating a chain from object to superclass, from superclass to subclass. This still works. Object has a no argument constructor, superclass has a no argument constructor which is making a call to super, and so on and so forth. So if it was in the case of class that doesn't have a no argument, that has an argument, a constructor with arguments such as this one, this is a constructor with arguments. It is in the superclass parameter is there, this one. So if I was to subclass this class, then I should see a compile time error if I don't include an explicit constructor. So Java only adds the implicit no argument constructor if there isn't a parameterized constructor in the super class. Okay, so this causes errors because the moment you add a parameterized constructor, then the implicit no argument constructor is not added. So this superclass parameterized class does not have a no argument constructor. So when the compiler attempts to add the no argument constructor with a call to super, it errors out, and because of that, it will request you to add a constructor that matches super. and you can just go ahead and do that. Okay, however, I won't be doing that, so that when you practice with the fresh code from GitHub, you will follow along. So let me just go back to how it was commented out. What you should walk away with from this, besides those facts, is there is constructor chaining. Beware of constructor chaining. And just to demonstrate, I will go back to our notes. In this case, we have object, superclass, was it? Subclass, there was parameterized one, and it's subclass there. So this takes from object, this takes from super. There is a constructor, no argument constructor here, implicit call to it here, another implicit call to the implicit one in super. But in this case, there is an explicit constructor, so there is no call to the default constructor, and this subclass would therefore require an explicit constructor that matches the parameterized class one. Next, we have object, our superclass, and equivalency. Please work with the description. There is a practice exercise on that. In the IntelliJ, if you click Ctrl O, it will, in this object method example, you will see the option to override several things. This is the constructor, default argument constructor, the hash code method, the equals method, the clone method, the toString, and finalize. So finalize is getting phased out. Make a point of copying javadoc or ensuring that inserting override is on. You can just say okay to that and read through. Get to understand this, work with the link that I've sent. I've included in the practice exercise in the description. To know more about this, you can also work with the official documentation link on object class. But the one that you might find very interesting is this one, the equals method, because that is the one that is used to test equivalency. Up next, final classes and methods. Okay, so our final class is a class that cannot be subclassed, and this is an example of a final class. We have a final class with that name. Yeah. Now, within the final class, you don't need to include the final keyword in a method, because every method in the final class by default cannot be overridden, because overriding only occurs after subclassing has happened. So there's no point with including this. This is why it's grayed out. So you don't need it, but I'll leave it there for your own practice and for your reference. So it cannot be subclassed, so it's pointless to say that a method is final in a final class. However, with another class that is not final, you can work with the final keyword for a method. This is mainly used for a method that is referenced in a constructor for the purpose of initializing. So for example, we have a method here that cannot be overridden, i.e. it cannot be changed downstream in subclasses to avoid inconsistencies in behaviors. So anytime you are using a method to initialize a constructor, make a point of making it final as good coding practice, so you don't get undesirable results downstream. This is a nice way in use of final method. Okay, if you attempt to extend a final class, then you'll get an error. So I will comment this out like I had before, but I wanted to use it to demonstrate that. So about final classes, they cannot be subclassed. About final methods, best to use those when you want to initialize a constructor, although there could be other uses, as long as you don't want them to be overridden. And you don't need to use final keyword within a final class because it cannot be subclassed, so overriding it can't happen. So there you go. There's some final classes in this. We'll actually look at some examples shortly. I'll walk you through that. Up next, we have abstract classes. and methods. And I'll also combine that with abstract classes versus interfaces, so that when I come back here, we'll just walk through these examples and you can have a look at them at your own time. I'll also include them in the reference in the description. So like interfaces, an abstract class cannot be instantiated. Unlike final classes, an abstract class can be subclassed. If an abstract class, or if a class has an abstract method, then it must be declared as an abstract class. So let's walk through that. I'll go step by step to make sure I don't miss anything or I don't misrepresent anything. If I do, forgive me, I'll clarify it. Okay, so I'll skip through, sorry, let me just start with this one. It cannot be instantiated. So if I attempt to instantiate this abstract class, I will see this error to either make it not abstract before I instantiate it or to remove this. So I'll just go back to commenting that out. So it cannot be instantiated, done. Can be subclassed. Let's go to this one here. This is a sub-abstract class and extending abstract class. So it definitely can be subclassed, unlike final classes. Must be declared abstract if it contains abstract method. So to demonstrate that, I will comment this method out, the abstract method, and remove the keyword abstract from this class. So if there is an abstract method, then the class must be abstract. So you either remove this abstract method or you add the keyword abstract as it was. Very good. Moving on swiftly with abstract classes, unlike interfaces, you can just have fields. Interfaces only have constants, but in abstract classes, you can have fields. And you can have different modifiers for your concrete for your methods. So in interfaces, if you need to have a method with a body, then i.e. a concrete method, you'd need to either make it default or static. Abstract classes and interfaces can contain abstract methods or implemented methods. So if it's an interface, it's gonna be a default or static method. So let me call this concrete method. That sounds better. So this is an abstract method, this is a default method, this is a static method, and this is a private method. Okay, since Java 9, this was allowed, private methods in interfaces. So when you're going through the official documentation, make sure that you're also updating your records. We now get to the implementation. So if it's an abstract class, it does not need to implement abstract methods. So let me just show us this a little bit. I'll go back to this class here. If there is an abstract method and a subclass has subclassed that abstract class, then it will need to implement the abstract method. Okay? Now, if it's an abstract class, then it won't need to implement the abstract methods, because an abstract class can have abstract methods, and when you extend, you inherit the methods of the parent. So there's a lot of maps going on here. In fact, just to make sure we've understood, sub-abstract and abstract class. Abstract class has an abstract method. Among other things. Sub-abstract has inherited from abstract class, which means that it can access this abstract class like it's its own. Abstract method, so like it's its own. Now here's the problem. This is not an abstract class, and the rule was, if it is an abstract, if it's a class that has an abstract method, then it needs to be an abstract class. So if it's just a normal class, you need to either implement this method or to make this an abstract class. So I hope that's clear. There are many rules that have merged into one here. and I've needed to clear that out for us. So I can either make this an abstract class, or I can implement the methods depending on our use case. So what I'll do, I'll just comment that out and move on to the other to this part. So an abstract class doesn't need to implement abstract methods if it in itself is an abstract class. So it doesn't need to implement abstract methods in abstract class if there were any, and it also doesn't need to implement abstract methods from an interface that it implements. So this can just stay as it is. Okay, moving on. You're feeling like it's too complicated, you can just take a breather and come back. We're almost done. So you might opt to work with this if you want to have clean code to clarify complexity, or if you want to offer flexibility in implementation. So we have interface here with several abstract methods, but sometimes when you're working with an event listener, you'll mostly see this in clickable objects or clickable items, especially if you work with either GUIs or JavaFX, if I remember correctly. So we have an abstract class here, event listener, that is implementing event listener. Now remember, if it's an abstract class that is implementing an interface, it doesn't need to implement the method, the abstract methods in that interface, but it can choose to implement the ones that it wants. So you have flexibility in implementation. For example, in this case, we are only implementing on click, okay, but we leave this as abstract to be implemented downstream in a subclass, in a subclass of base event listener. So in class custom bottom, or if in a subclass of base event listener like custom button that extends base event listener, and in that case it will need to implement the two methods that were left unimplemented from base event listener. Hope that makes sense. So why abstract is just another example of why you might need to work with abstract classes for flexibility in implementation. For example, we have this abstract class, database abstract. It has two fields, it has three concrete methods, and it has two abstract methods. So sometimes you might need to have flexibility in what you'd like to implement. Like in the case of my SQL database class, if it's extending database abstract, then it will definitely have to implement execute query and configure, same to Postgres SQL database. So the way execute query and configure across different databases might be different. So it makes sense if these ones are retained as abstract classes, while connect and disconnect are maintained, and they will be inherited as is unless they are overridden, because connecting to host and port is going to be the same. Disconnecting from host and such is also going to be the same. So if you ever get to the point where you're creating your own APIs or you're designing your own code from the bottom up, the different classes, make a point of using the abstract classes, the inheritance, the interfaces, the final classes if applicable. Make a point of remembering about chaining from the top up. If you forget, no problem, you can always refer to this session. When you get a chance to, look through the object class. As I had mentioned earlier, it's good to get to know about this, and I'll have you know that you'll get to see nice examples like this final class here. So we don't just talk about it, you actually get to see it being used in APIs that you work with. Have a look at clonable and learn more about the interface clonable. Have a look at comparable and learn more about it. Have a look at abstract map from Java language. API and how you can work with it, with its nested classes and so on. Have a look at, and please note it also has an abstract method, so these are not just concepts that are floating in the air, they are also used in Java APIs, like that example. Have a look at hash map, and more about it down here. Have a look at the string class and more about it, and I'll have us know that the string class is a final class. So if you ever hear that, at least it will make sense to you. It's a final class, meaning that it cannot be subclassed. Yeah. So very interesting concepts. Have a look at those examples for more if it piques your interest. That has been our very, very, very long inheritance session. Stay tuned for more.